Hi, this is Francesco, and this video is a quick walk through my project. I have already posted a demonstration of what my project is in action, and in this video I'm just going to quickly run through how it all comes together. So before going to the Unreal part and all that stuff, I'm just going to tell you that it requires some external software to actually be run. It requires SteamVR, it requires Kino VR, and its Kinoni counterpart on Windows, or any other streaming device that can take SteamVR and send it to your phone as a stereoscopic VR Google Cardboard effect kind of thing. I've tried Trino's VR, I've tried others, and I've finally settled on this because it's really fast and never noticed any latency issues, so pretty good. Then what else? Unreal Engine, of course, and Visual Studio or an IDE. In fact, let's just say Visual Studio because this project really is for Windows. There are so many bits and bobs that wouldn't work on a map. Yes, there is source code, yes, you can adapt it. Good luck if you want to do that. And so yes, let's say you've got Stream, you've got everything up and running. So what you do is you open the project. I've already got it open, and you're into the Unreal bit. Now, before I start to talk about the Unreal bit, I'm going to talk about the audio engine. Now, this comes into the file, it comes in the repo, but you need to copy the files across into Open Frameworks because it's coded into Open Frameworks, and you require to compile it. So you need Open Frameworks, you need to transfer the app, which is this bit here. Oops, not. It's this bit here, live granular, into the Open Frameworks My Apps. And then you will also get two add-ons. One is this, one is this. They have to go into the add-ons folder. It's pretty self-explanatory. It's this bit here. You just need to bring them there. Once they are there, this is fine. This is the Unreal Engine program, and it can be run separately. That has to be compiled, and you have to obviously run it because that's the audio engine, which is of course separate. It's based on Maximilian, and what I've done is I've taken an existing live looper that would granulate the audio that is being recorded onto this loop, and I have tweaked it. I've added functionalities and all this thanks to my friend Pavel, whom I really wanted to thank because we've managed to code this whole thing in one weekend, and without him that would have not been possible. Now, his work on it allowed the original plugin, the original Open Frameworks app to be compatible with Open Frameworks 9 on a Mac. I have made it compatible with Open Frameworks 9 on a Windows. And what we've added is other bits and modifications that allow the graphics to be better. You can actually see the tape head and the live recording of the waveform as it is written onto the buffer and onto the recording, and it allows you to control everything through OSC, which is the good bit, because the whole point I was making to Pavel was to have an engine that could run without a keyboard, without an external controller. I want to control the parameters through my Unreal Engine, my Unreal interface, my software, my AR, but I didn't want to actually play things. I didn't want to actually start, mess around with playing a keyboard or things like that. I wanted to run and just run. and this is perfectly fine. Also, it satisfies the kind of audience I thought this will interest, or there is experimental musicians who really like electronics and weird tech like I do, and playing electronic music and granulated leads and live loopings on top of, for instance, a separate drum machine that runs, and having virtual controllers on top of their actual controllers, and not having to worry about what's being granulated because everything can be controlled from Unreal and nothing needs to be keyed in, as in piano keyboard keys, then this does it. And it's the typical OpenFrameworks main with OFUp. It draws stuff into OFUp, granulates stuff into the granulator, which is based on the Tweak OFX DSP chain that we've made and modified, and with the OF Maxim loop record hack, which is based on the Maximilian external for the Maximilian add-ons for OpenFrameworks. Once this is all up and running and it receives OSC and it's ready to receive OSC, it needs to be connected to this. The way it's done is by sending out OSC. This then picks it up and it adapts it, and it reads the IP, and then it has a port which hopefully the program is prepared to receive, and they can talk to each other. What this project actually does, well, first thing, you need some hardware for it. You need a leap motion, you need a webcam, and you need a Google Cardboard mask. Now, you get cheaper one than this. This actually was £20 on eBay, but it's not about that. You need something that isolates you. You need to put your phone in there, then your phone needs to stream from the app that I just showed you. Once you have all this stuff, and they're all plugged in, then you can obviously run it like I've just done to show you now. And once you're running, that stereoscopic image is sent to the phone through the streaming software thanks to Steam VR, which I guess reckons it as a game, and I just find it lovely that Unreal can integrate, because it's making this whole project easier. Now, the plugin used, I've used the integrated plugin for Leap Motion. I've used the augmented reality plugin based on the AR Toolkit framework, and the OSC plugin. This is from Monsieur Gustave and it's downloaded from GitHub, and I compiled the project once I put the folder with the source code in there, so that Unreal can read the source code of this and send OSC in and out. And that was relevant to my technical research I did about OSC, because it was very easy for me to implement everything I've done in OSC. In fact, I did it in one day, because all of this and the other OSC in the other app are based out of the way OSC is handled by C++, which I know very well because my technical research was literally about building an OSC parser, receiver, sender, and thread creator and destructor in C++. And aside from all this, let's see what I've actually done here. There is a level, and there is a cube which is flattened, which I've texturized, and I'm texturizing it with the streaming from the camera. Now, there are two screens, in fact. One which is attached to the actor, the main character, which has the camera position, and which is basically it's where you are in the game and what you see through the game. And because this is texturized with what comes in with the camera, you can see here, create dynamic material instance, set texture parameters, value, then obviously it looks like you're seeing through. That's why the AR effect works, because you're actually looking at a panel which is texturized with the input from the camera. And to make all this work with virtual objects, what I've done is that I've then created a scene which does exactly the same thing. This is the level blueprint that does that. The only difference is that the AR toolkit component takes in from the camera the marker that I've selected, and it comes with the plugin, by the way, and it calculates the position of the camera as in real space as compared to that, as relative to that marker, and then it converts it into a camera position in digital space, in virtual space, and so in a rotation. Now these parameters are used to set the AR toolkit base advanced, position and rotation, and that actor is none other than this actor, which is your character. So you're going around because you're moving your head. Wherever you do, you look like you're moving because you're seeing the screen texturized, so you're actually seeing yourself moving around your head. But what happens is that if there is if the marker is being detected, then this whole actor, including the screen, is moved across the level. Now, how I added the user interface? Well, I've basically placed these objects, these virtual objects, onto another screen. This too is being texturized. However, the texturization of this is handled in a more complex way by scaling, basically, and by scaling the image based on the camera resolution. I've had to hardcode a little bit of a value here, otherwise my webcam wouldn't work with it. And this is all dynamically changed, basically based on all the AR toolkit information that we're getting from the AR toolkit. Now this is just taking the mesh information. This is literally it. Now, this way of texturizing means that the texture changes dynamically. So whereas this one has always the same texture, because you're always at the same distance and looking at the same thing, because as you move, as this whole actor is moved, the relationship between these two don't change. It's the whole actor, it's the whole character, and this is part of the character. It's the whole character that changes. In this particular case, the character is being changed by the level, by the game, relative to this, which is the scene, which is the background. It's it's the 0, 0. Now, as it moves, the texturization of this changes, so that when this and this screen collides and intersect and superimpose one over each other, and you can see, you don't notice that because this has been texturized in a way that it looks as if you were looking at this, and this was just a transparent bit in between. It's basically just calculating the perspective and then stretching the texture to make it look as if this was just a portion of this viewed from an angle. And once that was done, I've got two texturized things that keep being updated and two texturized cubes that keep being updated and look like screens, and you basically always see through. These objects here lay on top of this, and let's have a look at the level. When the marker is visible, is detected, they are not hidden, so you can see them. If you can't detect the marker, they're hidden, so you can't see them. And that's because obviously you cannot update the position, and otherwise you would have them stuck in your field of view, and you would move around and they would not move, and it would destroy the AR effect. Now let's say that you can see them, and you're seeing them because you can see the marker. You can actually go and touch them, because what happens, and this is the last bit of my project, is that I'm getting data in from Leap Motion. Most of the low-level stuff is handled by the Leap Motion plugin itself. I've got loads of built-in functions that I can use. For example, if a circle is detected, or if the position of the hand needs to be moved. Now, all that is basically handled for me. I just have to call the right thing in the right way and then scale it and translate the position of the virtual hands in this actor the right way. And that is done here. When I do the scaling and everything, the hands basically match what you see on the screen as the hands that you get because you're looking for a webcam. And the project works because this actor, you know, this background and the various objects on it, and this macro actor, which is this, you know, it's sorry, no, this is an actor which is child of the main actor. So the hands are a child of the main character actor, and you go up inheriting stuff up the level. Now this inherits interfaces, and so these actors, all of them, the cubes on all the interfaces, all the user interface stuff, know of the existence of interfaces, which are just the empty shell of the functions. This character implements this interface, inherits them, and then implements the functions. For instance, OSC interface has a trigger function. It also has a rotation function. Let's say on the trigger function is just that. It's an empty method. Because this thing inherits it, because the character inherits it, I can now say, okay, well, you are inheriting the function. There we go. It's done here, in fact, trigger. Call it. Sorry, not call it. My fault. What do you do when it's called? This is the implementation. You check a few things and blah blah blah, and basically you create an OSC message and you set it, and then there is another part of a script that sends out OSC. It's basically a ticker that constantly sends out OSC if there is a change in the OSC. But that's not concerned about with that, because that's just coding. I mean, something I've done, but it's basically quite basic. But this is updating the data, and it's sending out the OSC, and this is the implementation. Now the sphere, even though when the level spawns all this stuff, doesn't know anything about the character, where the character is and what it does. What it can do is that it can detect collisions with other characters. It can then cast the reference that it gets from the collision, or it can check, does it implement the interface OSC? If it does, then surely we can call that method. We don't know how it's implemented, but we can call it. And when we call it, then there we go, it gets called and it gets acted upon. And through this way, I've implemented a rotation method that takes in, that when it's called, it sends a reference to this very object, say a sphere, onto the collided object. The collided object at that point has a reference, and it casts that reference as a static mesh actor, and therefore if that object is a static mesh actor, this casting is successful, and you know that a static mesh actor has a rotation in space, as a rotation value on X, Y, and Z, and I can use two of them, for instance, like I've done here, to change the speed and the pitch in the OSC driven audio engine. Trigger can change other things, and so forth. And this idea of using inheritance and passing reference is really powerful, because it allows me to create two independent things, two objects, two actors that can inherit from other actors, that can inherit, from interfaces, and that can spawn children on like the hands, and then everything can be connected, and every part can know only what they need to know, and the level can go on having everything linked up together. And finally, once the message for OSC is being used and detected and created and added onto the stack, and the ticker knows that there is something on the stack, so it sends out. It can be picked up by the audio engine, and it just works. Basically, this is how the whole project comes together. And the last thing on this, there are also methods that I've used to pick up objects. They work the same. The event is called because of the collision, and then a location and the reference to the object is passed on to the character here, the leap motion hands character, and then I use the Euclidean distance to know which hand is closest, get the mesh from the hand, and attach the mesh from the actor, which is colliding, with the mesh of this hand. And I can do that again because of the referencing. So finally, the engine knows, the Unreal Engine I'm talking about here, knows that now these two meshes are attached. So if you move the hand, the sphere comes with you. And if you turn the hand, the sphere turns, because it's grabbed, it's in your hand, it's attached. If you release the grabbing gesture, very simply, the objects are detached. And now they're two independent actors, they move around the scene independently, so obviously, since spheres are subject to gravity, they will gravitate towards this, and it will look as if they were going further away from you and stop at some point. Now, it will look as if it was in midair, because really this is just a projection of what you see from the webcam. So it would not look as if they fall, say, against the wall of your room, because that's just not what it is. They will fall at a point which is where the 0 is. It's not even where the marker is, because actually I've translated this. This is 0, but when I've made the level, I've made the 0, sorry, I've made the translation of this be slightly apart from the 0. I think I set it as I think it's here. No, it's not. Well, it's somewhere in here. And there we go. It's just the virtual distance that there is basically between the marker and this point, which is the 0, 0. It's just the way I translated this starting bit. And this is it, really. Let's see how bad did I do this time. 23 minutes video is actually not that bad. I think I've covered everything. All the software that you need to run this, Open Frameworks, Unreal, everything, and the hardware and how Unreal works. So I'd say that this is all for me. This is the behind the scene. Any questions, anything, you can just comment on the video on YouTube, or yeah, actually that's the way. Hope you enjoyed it. Thanks for watching.